Welcome everyone to the Fermentation Association's webinar of Managing Microbiomes to Control Quality. I'm Amelia Nielsen-Stoll, editor of TFA. We are a trade group that was launched to support producers who use fermentation to create delicious and often healthful food and beverages. Our goals are to help educate consumers about fermentation and its benefits, support scientific research into those health benefits, and work with food safety authorities to establish clearer and more appropriate regulations in regards to fermentation. Today, we bring you 5 great speakers. Dr. Ben Wolfe of Tufts University, Dr. Maria Marco of UC Davis, chef, author, and consultant Cortney Burns, Jasper Hill founder and cheesemaker Mateo Kehler, and Wildbrine quality assurance manager Olivia Slaugh. We have many questions already submitted and reviewed with our speakers. If there are additional topics you'd like to see addressed, please enter them in the chat below and we will try to get to them. I will come back at the end to ask some of our audience questions, but for now, I'll turn it over to you, Ben and Maria.
Thank you, Amelia. So my name is Maria Marco. It's really a pleasure to be here. I'm a professor in the Department of Food Science and Technology at the University of California, Davis. I'm a microbiologist by training, and I have a wide range of interests in fermented foods, from fermented dairy, plant-based foods, meats, and interested in quality, how they're made, and also the health benefits that these foods may give. So I'm going to turn it over to Ben to introduce himself and the panel.
Great, thanks, Maria. I'm also really excited to be here today with these amazing panelists. I'm at Tufts University, where I'm an associate professor, and my lab studies the microbiology of fermented foods, including things like kimchi, sauerkraut, sourdough, cheese. And we're really interested in sort of the basic biology, how microbes work, how microbiomes form and function. And we also do work with fermented food producers to help them understand how to manage microbiomes, which is a big theme of today's session. So before we turn it over to our panelists to introduce themselves, I just want to give you a little bit of background on how Maria and I developed this session and sort of why we developed the session. And as you're going to hear about today, producers of fermented foods rely on microbial communities, or what we often call microbiomes, these collections of bacteria, yeasts, and sometimes even molds to make these delicious products that we all enjoy. And something that you can learn more about in terms of the microbiomes would be in a session that Maria and I did for the Fermentation Association back on June 16th. And you can check that out on the YouTube channel for the Fermentation Association. And so something that sort of fascinates all of us, I think, that are here today is that fermenters use these microbial communities every day, right? They're working with them in crocks of kimchi and sauerkraut. They're working with them in a vat of milk as it's gone from milk to cheese. But yet most of these microbial communities are invisible, right? We're relying on these communities that we rarely can actually see or know in great detail. And so it's this really interesting challenge of how do you manage these invisible microbial communities to consistently make delicious fermented foods. Sometimes things don't work out when you're making a fermented food and you have quality issues. And so one question is, how do you then begin to explore the microbial origins of those issues? What kind of data do you need? What microbiome sampling, what might you need to address those issues? And so that's a really big theme of today, is sort of how people working in different parts of the fermentation space work with these invisible microbial communities and sometimes make them visible through various types of data that we'll talk about today. So I'm going to turn it over to first Cortney, then Mateo, and then Olivia to introduce themselves and just talk a little bit about where they're at, what kinds of foods that they're making, and sort of maybe how they got into fermented foods as well. And then we'll start off with our first big question. So Cortney.
Thanks, Ben and Maria. Grateful to be with you all today. My name is Cortney Burns. I am a chef by trade. I've been in the culinary industry for the better part of 2 decades, mostly in restaurants. And with that exploration came a deep dive into fermented foods. Currently today, I am consulting with Blue Hill at Stone Barns, which is in Westchester County, north of New York City, where we have a farm and a restaurant directly connected. And I am heading up their preservation and fermentation program currently. So I got into fermented foods on kind of the non-sexy side of fermented foods because I didn't feel well. And so I went to a naturopathic doctor, as much the story we all know very well. And that doctor had me make sauerkraut and water kefir. It'll come to no shock to any of us that I started to feel better. And a lot of those flavors, especially the sauerkraut, were flavors that started to bring up this resonance from my childhood and my past and my Eastern European heritage. And there was this innate knowing. And so it became a part of the kitchen. And one of my restaurants, we started to just kind of ferment everything in sight. And so that's how I fell in love with it, as not only a nutritional powerhouse, but as a flavor agent as well.
Awesome. Thanks, Cortney, for being here. On to Mateo. And we'll just make sure you're unmuted, Mateo, so we can hear your amazing voice. Thanks.
Sorry, how many times have we had to go through that this year? I'm so grateful to be here with you and to share and to learn. I came to cheese really as a means of making a living up here in the middle of nowhere in northern Vermont, and have embarked on a great adventure. Had the privilege and the pleasure of getting to work with Dr. Ben over many years, and as such have really developed an ecological approach to cheese making. And for us, cheese making is a vehicle to accomplish all kinds of other economic and social goods within our community, and we're leveraging the power of cheese to do that. But ultimately, we see fermentation as a way of really adding value and creating truly place-based products that reflect both the people and the practices within our business and our production system. So we milk about 200 cows, and we purchase milk from a few neighbors. We milk 450 goats, and we make a variety of raw and pasteurized milk, all natural rinded cheeses, and look forward to sharing a little bit more with you as we go along.
Thanks, Mateo. Olivia.
Oh, hello. My name is Olivia Slaugh, and my whole career in food has actually been in fermented products. I am a microbiologist. That was my educational background. And then I joined fermentation first in traditional dairy, very large scale traditional dairy, actually, very large blocks of cheese, milk powder, large ferments. And more recently, I've actually moved to a little more artisan cheese in between, some goat's cheese, as well as some lactose-free cow, yogurt, milk kefir, and that is a cup set yogurt, so ferment in the cup. And then to vegetable ferments with my current company, vegetable and plant-based products that are traditionally made with milk. So plant-based cheese, sour cream, dips, those kinds of products. So yeah, that's my specialty, as fermented foods of a couple of different stripes. And my current company really focuses on the plant-based ferments.
Great. And what I love about this group of panelists is we sort of have all different scales of fermentation, everything from in the restaurant to larger plant scale. And I went large, it's not, major corporations, but large for artisan ferments. And so what'll be interesting is sort of to hear about the different challenges and issues that you face along the way with quality. So our first question that each panelist is going to explore is just a broad overview of the types of microbes that they're working with. So what are the main ferments you're making, and what are the main fermentation microbes that are there? Maybe a few different ways that you're aware of the microbial quality connection. So how do microbes impact quality? And also, what are some just general indicators or tools that you use in your products that you're making to assess the quality of your ferments? And again, we'll start off with Cortney.
All right, thanks, Ben. I'll try and answer all of those questions. In the kitchen currently, because we're small scale, we really get the opportunity, I think, and even in large scale too, but we get to play in a multitude of different arenas. So we work with lactic acid bacteria in a bunch of different ways. We work with acetic acid bacteria. We work with a lot of aspergillus mold, and we're, fermenting and pickling fruits and vegetables. We cure meats. We work with dairy and make different dairy products, and lots of koji-based products. So soy sauces, misos, amazakes, daoshi, and the like. So we kind of span, a few different bacteria strains, a few different microbes throughout the work that we do. And I would say one of the main ways that it impacts the quality of our food, and it probably sounds really basic, and hopefully this answers, this is kind of in the vein of what we're looking for, is it preserves it for us. So not only are, we're really working with fresh products that are coming from the farm or that are coming from local farmers, and we're trying to find ways to preserve them so we have them for longer, but also to uptick the nutrient density within them as well. So those are two kind of major facets of what we're working with. Although, we have access to food in a different way than we did, hundreds of years ago, we're still working with necessity in the way that we preserve food, because we are very locally based, farm-based, and seasonally based. So we do preserve, so we have more nutrition, flavor, color in the middle of winter, but at the same time, we're amping flavor, we're amping nutrient density in the work that we're doing. So I would say also that in the question of what are some indicators, or, I think you asked examples of good and bad aspects. One of the things for the different microbes that we're really trying to do, because we're working with so many different microbes, is when we have some of our mold-based fermentations going, we really want to ensure that we don't get lactic acid bacteria in there too quickly. So if we do, we sour our misos, or our amazakes go sour. So we have to be really clear about how we're holding things, at what temperature we're holding things, where they are in our space, so that we're not producing lactic acid when we don't want it. We want it later on in these longer term misos, but we don't want it early on. So that's something that we have to continue to watch out for. And as far as the tools we use, like some of our vinegars and some of our ferments will use pH tools, but I would say more often than not, we're just using our mouth. And so for us, that is the most technologically advanced tool we have, at least in our daily kitchen. And then we reach out, luckily, to people like Dr. Ben, and we get to work with him to find out more of what's going on. But on a daily basis, it's taste, smell, feel, just sort of that innate knowing on whether a body wants to eat it or not.
Awesome. On to Mateo. So again, what are the main groups of microbes you're working with, how they impact quality, and what are some tools you use?
So we work a lot with raw milk. So in some ways, we're beginning with microbial ecology of our farm and our farming practices as like the fundamental base. And we can get into that later, and perhaps, but when things are going well, and we have like a balanced microflora coming through our raw milk, oftentimes things will continue in that trajectory. When things go awry on the farm, if there's cleaning issues or a contamination of our feed or the animal environment, we'll also see issues in the finished cheese. So it all starts really with the farm, our farming practices, and most specifically our forages on the farm. We only feed dry hay. We work with lactic acid bacteria primarily, but also a range of what we consider ripening flora, and those tend to be gram positive bacteria. They're rind microbes, and they're both we've got like a range of different staph species. We're working with yeasts like Geotrichum candidum and Penicillium, Roqueforti, and Camemberti, as well as a range of really flavor producing bacteria that are, express flavor when they're in community, right? And so this is one of the really interesting things that we've learned, is that oftentimes the expression of sensory attributes that we're looking for only happen when we are able to assemble, or when the right conditions exist for the expression of certain like flavor characteristics. We use pH meters to monitor acidity. Moisture in cheese is like fundamental. And along with measuring moisture, we actually measure fat, because it's really about available water and to support like the microbial communities we're looking for. And we measure salt. And beyond that, we do a lot of tasting. So the tasting is what brings us all together, whether we're on the farm or cheesemaker, or working in the cellar, or in sales, or even on our admin team. Like sensory is really like a unifying experience for us, and basically connects the dots for deliciousness.
Awesome. Olivia.
There's a lot of commonality in this question at all levels of our ferments. Similar with vegetable or with the dairy, lactic acid bacteria are pretty commonly used thread. So we have that. My current company for the vegetable ferments, kind of like the raw milk explanation, is a wild ferment. That's where the wild and Wildbrine comes from, is the wild ferment. So the existing ecology that comes in on the cabbages for the kraut is really important and can vary. And so you have to be able to respond to that, principally with, of course, the pH meter, salts. That's true of both dairy and the vegetable ferments, really important things to measure. But also, of course, there's nothing that replaces the organoleptic analysis, your tasting, your analysis of texture, and really having people at all levels of production, quality, administration, same as Mateo was saying, intimately familiar with the standards for the product and the expectations, so that you can identify drift. If you do have drift over time, especially slower trends is one of the challenges to keep on top of, when you're not just comparing today to yesterday, but you're comparing today to this time last year or this time 2 months ago. Those kinds of things are something you have to build systems around to really monitor. In addition, for the plant-based part of the line, we do use some of the Geotrichum penicillium type of organisms for a bloomy rind that were previously mentioned. So that is something that you can absolutely also apply to plant-based cheeses as well.
Excellent. On to Maria for the next round of questions.
Thank you. Great introductions. And this really leads into the next question. You know, our fermented foods are much like gardens, or if we're, you know, we're farmers, right? As Dave Erith said previously, we're managing our microbial farms really when making fermented foods. And, you know, if you're a farmer, you know that you're really subject to the conditions, the weather, the, you know, all sorts of variables, because these things are alive. And so, you know, although we'd like every ferment to turn out perfectly, we know that's not always the case. So this question goes really to this quality issue. And we'd like if you could share an experience you've had in managing your ferments to improve or control quality. And sort of embedded in this question is, you know, assuming there might be an issue now and then, when did you first notice it? And were you able to alter the course of that ferment, or revisit or readjust? And then what, you know, what types of sensory or other observations led that effort to manage your microbiomes in fermented foods? So starting again with Cortney.
So for the record, I've had so many things go wrong. I mean, it's just kind of what happens over time as you learn. And the best way to learn is through they're making, I mean, whether it's mistakes or, just things happen. I mean, these things, as Maria is alluding to, they're alive. So it's a constant conversation. It's a relationship, really, that we're having with each and every one on a different level. And some of these relationships, like any, fall to the wayside, or we forget about them, or they don't give them the attention they need. And that's really a determining factor, I feel like, as far as how things move forward in their fermentation process and how they either succeed and or sometimes fail. One of the things that comes to mind is we used to make a lot of water kefir at one of my restaurants. We always had water kefir as one of our fermented sodas and whey-based sodas on tap at all times. And every once in a while, our water kefir would get really ropey, and I had to ask the name of this bacteria again. It's leuconostoc. And at first we would throw it away. We'd be like, this is terrible. No one's going to want to drink this. It would be hard enough to get the grains strained out of it because it was so thick. But then as we learned more about it, we're like, what happens if we just leave it for a couple more days? And we learned that this is a bacteria, or a microbe that comes in early on and can get out competed as the other microbes come in. And so that became a sort of experiment. And every once in a while when it would happen, most of the time it would go away if we just kind of let it be, made sure the conditions were right. And we noticed that if it was too warm in the back room, that's oftentimes when that would start to take over. So drop the temperature, check that everything's stable, and then, move forward with that. We've had ferments that get really soft because the AC has gone off, let's say in the back room when we're fermenting. And so all of these things. So really, I mean, as Olivia is alluding to, we don't always have the same conditions and protocols necessarily, or space to do all these things in small restaurants, but we try our best to still work within kind of the known kind of boundaries that we have to work with these ferments. So, same thing, we've had koji that fails because the sensor falls out. And so therefore the heater doesn't know, what temperature it is anymore. So all of these little safeguards need to be put in place in order for us to have kind of continual success with what we're doing. But we always learn from it. We move the sensor, we drop the temperature, we leave things for a little bit longer. And, that's kind of how we end up manipulating them, is just creating an environment that we know they're going to thrive in. And again, that sort of data and sensory observation really is just, it's sensory. It is at the most basic level. It's a tactile experience. And so that's really how we work with both, like I said, the successes and the failures throughout what we do.
Fantastic. Mateo?
Well, we really take this idea of selective pressure to, we bring this idea of selective pressure to managing, quality across our production system. We make a range of different types of cheese. We make blue cheese. We make like white mold, like bloomy rinded cheeses. We make those cheeses in the same production facility, in the same space. People told us it was that was impossible. But if you understand the ecology and you can apply selective pressures properly, you can really get the microbes you want to grow where you want them to grow, while really using what we call technological hygiene to exclude or outcompete microbes that may be problematic. We have learned a lot over the years, and never by doing anything right. We've learned everything we know by making mistakes. And I was trying to figure out where to start with this question, because we've had so many things go wrong over the years. But most recently, we had an issue with Aspergillus colonizing the rinds of one of our hard cheeses, and really creating conditions for this kind of wet intrusion into the rind and spoilage of the cheese. And that was really related to lapse early on in establishing a good rind on the cheese by washing that cheese to create a protective and like a protective community early in the cheese's life. So we're talking about the first week of this cheese's life. It was like having a baby, naked, exposed, without really kind of, putting the elbow grease into scratching it up and creating the nutrient for coriniform and other yeasts to colonize that rind early. What was happening was, and the temperature is a little warm, so it was like favoring Aspergillus, which was able to establish itself and would express later in the cheese's life. And we've been essentially able to eliminate Aspergillus from our cheeses at this point, just by exerting a little more elbow grease and washing those cheeses more aggressively, starting on day 1 after their arrival at the cellar. Another example that we've dealt with is sporadic infestations of mucor mihe. It's like a gray mold that can colonize. It's a seasonal contaminant, usually in the spring and fall. It's associated with vegetable, like rotting leaves. In the fall and spring, you see it quite a bit, and it would establish itself on our bloomy rinded cheeses. And one little mold has like 10,000 spores, and so it can spread, and it's incredibly aggressive. We were able to essentially eliminate mucor from our production by leaving the young cheeses in a warm environment, about 65 to 68 degrees for 2 or 3 days before we moved them into the cellar. And during that time, we saw like a lot of yeast development, and that really created a protective colonization of the rind, which excluded mucor. So just by manipulating the temperature for strategically for just a day or two at critical moments, you can really steer a community one way or another and exclude unwanted microbes.
Thanks, Mateo. We have whole conversations on each of these responses, but we're going to have to move on to Olivia.
All right. I have 2 examples of times when microbes really impacted quality. And I think it's really important, especially as somebody who primarily works in quality assurance and primarily at a larger manufacturing scale, where, of course, not every ferment turns out. That's, as we mentioned, that is just sometimes it happens. But the pressure and in some ways the urgency of that diagnostic process is felt acutely at all levels, but especially so when your batches are hundreds or thousands of pounds of raw ferment, and the ball keeps rolling and you have certain commitments to make. I know that affects, of course, businesses of all sizes, but when you can see hundreds or thousands of pounds, it makes a big difference psychologically, if nothing else, but certainly on business. So I think it's really important to draw a distinction between when you have a problem from what I'll call intended microbiology, the microbes that you intend to be there, which at one point in your process might be entirely a beneficial thing. And at another point, if things go not as expected, can actually become a spoilage organism. Lactic acid can be this way, or even if it's not traditional spoilage as we normally think of it, but it's a packaging defect. Those sorts of things can certainly happen depending on how the management goes. And then, of course, the other side of that coin is unintended microbiology or a contamination event, kind of like Mateo was talking about. So my first example of that with intended microbiology is a good example of reverse engineering your process in a sense. There is a big difference often between benchtop scale or even small scale, and then what happens when you go very large scale. My personal thing I usually say on this is you're exceedingly lucky if 70% of your information transfers when you scale up. That would be, a dream amount of similarity. There is just a lot of things that happen in scale between thermal mass and heating, and the often forgotten about part when you're charting things out, how long it takes to cool, because temperature being so important for a lot of these ferments, the amount of time that it takes for you to slow, or not exactly stop, but of course slow your fermentation for packaging purposes really matters. So my example of that is doing yogurt. We know that ferments can take various amounts of time. We can be talking about days or weeks or months even, or we can be talking, as in this example, of a couple of hours. For something that has a turnaround time of about 4 to 5 hours, you have to consider pretty carefully the cooling time, that suddenly when you have a pallet of this product together, you're probably talking on a couple hours to cool to the point where you've significantly slowed your fermentation. So for example, you can have your yogurt cup setting and being a thermophilic, though it of course occurs with mesophilic things, like sometimes you'll do sour cream that way, but a thermophilic bacteria doing its job. But in this case, we had to avoid excessive tartness because we didn't want to run it to terminal. We didn't want the most change in pH we could get. For flavor reasons, wanted a middle value as your endpoint. But of course, we had to figure out, when do you move that to being chilled? When do you take it out of your fermentation zone in order to have a final chilled product like the customer is going to see that you like? So moving that and doing studies between, well, the outside of the pallet takes X hours, but the inside, being more insulated from the cooler, takes X plus Y hours. And it depends on your cooler too. So that's the kind of thing you have to really find out in your own production space, and you just can't replicate at a smaller scale. You just, unfortunately, just have to do it at larger scale. In that case, the defect we were seeing was excessive tartness, or if you don't get it in the cup fast enough, if you have a production delay, you get an extreme graininess, solids settling out if you try to cup fill a not completely ready yogurt. Get it in when it's milk consistency or when it's a blended set consistency. In between, you'll have major quality problems, and that's just the efficiency of your bacteria. So, for example, you can reverse the heating and chilling of your tank and chill it down, buy yourself some time, slow that ferment down so you can resolve a production issue and get it in the cups at the appropriate point. Otherwise, you'll have a major texture difference. The other example of unintended microbiology happened when I was working with, at one company with a plant-based cheese. And that diagnostic process was very different. In that case, it was an entirely bacterial ferment, so all lactic acid bacteria, but it was a yeast contamination. The first thing you always see, or typically see, is the defect, not the cause. So step one tends to be isolating what is the probable cause, using something like the fishbone analysis or the 5 whys to really drill down on not the symptom, but the illness, so to speak. And that can actually be very difficult when everybody's so stressed about, we had to throw away X thousand pounds of product, and we really need to ship out next Tuesday, that kind of thing. That can get lost in the shuffle. So a lot of it is managing. In that case, with that cheese, not only was the problem bloating packages that were quite inflated, it was a film type packaging. So it was a very profoundly obvious defect, and unfortunately not one that showed up right away unless you subjected the units to stress. So stress testing was something we had to develop, and figuring out how old minimally does the packaged product have to be in order to generate the defect in the first place. So what is your testing window, so to speak. And then because of its intermittent nature, where is it coming from? And when it was really binary, like it was in that case, where you either have none or nominal levels and you don't see the defect, or you have incredibly high yeast counts and the profound defect. We didn't really have a lot of in between. It was either completely inflated and spoiled. There was also, of course, a flavor, as you might imagine, with that kind of yeast, a very effervescent, yeasty, almost brewery kind of sense, which is not what that fresh cheese was supposed to be in any capacity. So drilling down on that, my best advice for that and what really works in those kind of situations is, as a quality assurance person or a production person in charge of these kinds of defects, is you have to be on the floor. You have to watch it being made, and you have to track samples from various points to see where your introduction is. Intermittent nature like that is likely to be a harborage point. If it's none or a huge amount, it's probably not just your air. For example, where we might think yeast and mold would be classically perhaps an air or even perhaps a tool touching contamination. And now I should say that this yeast was not used anywhere within the facility. It was definitely a wild type. We identified that it was a yeast through a very general yeast and mold test, knowing that there shouldn't have been any. So if I found a bunch, there's my smoking gun, so to speak. And knowing that yeast has a very significant capacity, at least a good number of them, to create this kind of gas and inflation. So really going out there, taking a lot of samples. And I would always recommend, if you're large enough that you're industrial, you probably have, or you should have, a process flow diagram of some description to really outline your processing steps, as you'd need for an audit or for a great number of both certifications and government regulations. Of course, depends on where you are, but in any case, and really look at the things between your steps. I'm talking about things like, what scissors do we cut open the ingredient bags with? How do people change their gloves? What are the touch points? The things that you would never put on a long form process document because they're just the minutia. You just write added to mixer, for example, or, churn turned on, for example, and churn for a certain amount of time. In that case, to make a very long investigation story short, we actually found the source, and the reason why it was intermittent was on a particular container that had an inner liner that then contained an ingredient. It was actually an ice that we were using. And despite the fact that the manufacturer was sending us a food grade, or in some cases a medical grade ingredient, the container does not have the same level of sanitation. So you can't really take these things for granted. Your COAs are, of course, really important. You have to have great supplier oversight. That's something that's stepped up a lot regulatorily, even in the last 5 years. And the enforcement's gotten better. But you can't just assume, oh, that comes from a company that does this all the time. Of course, their container is going to be fine. Well, and it all depends on whether the inner liner happened to brush the outer box. And it can be things like that. So really drilling down on those investigations and being very focused on, even though it seems silly, usually when I'm told, okay, we're seeing this defect, describe very particularly, what is the defect you're seeing? Do you have any samples for me? How frequent is it? When are we seeing it? Where are we seeing it? Give me a pattern, because once you start to have a pattern, you can start to find things out about the pattern. So I apologize, went a little off script on that, more into the resolution side. I felt like the elements of the defects and stuff were really well covered by Mateo and Cortney. So, but that's my two examples.
Thank you so much, Olivia. Wow. And just speaks to the expertise that you and our panelists here bring, and how important that is, and managing our food ferments, and also how individualized from the kitchen. Each kitchen is different. Each processing facility, each packaging facility, you really have to tune in to what is happening and understanding the nuances, or trying to understand the nuance within a site. Also, the importance of kind of informed trial and error is what I'm hearing in this conversation. So that leads to our next and last question, and one that's future forward thinking of kind of where we are today and where we need to be to help, whether we're making it in the kitchen or in large small scale companies, how do we get our fermented foods to the next level? And so, in your views, what sort of data, tools, resources are needed by fermented food processors to sustain, improve quality, and to, manage our microbiomes, essentially? Really interested in your perspectives here. Cortney, do you want to lead off again?
Sure. So this one, I mean, there's so much to say on this one. It's interesting to hear you kind of speak to the different sizes here. Just one thing I want to note, just to kind of circle back on the other one quickly, is in the restaurant, we have things coming from everywhere all the time. We work with so many different farmers. There is no control status, no control bank that we're working with. So that's something that's really interesting with the yeast. They're jumping off of the fruits. They're everywhere. So as we move forward, we're hoping to build out actually a very specific lab on site at Blue Hill at Stone Barns, where we can start to do this in a more controlled environment, which leads directly into this question. And I feel like, for me, especially hearing Mateo and Olivia speak, from chef's perspective, I only have so much scientific knowledge. I have the desire to always know more. It's continual learning process. That's the beauty, I think, of the kitchen and the culinary arts in general, is there's no lack of something new to learn. And every day I step into the kitchen, I learn something new. And that's the beauty of it. But within that, that means that there's a lot of unknowns. And so I do as much research as I can. I learn as much as I can about what's actually going on so that I can set some of these parameters in place. But one of those things I think that's kind of going to catapult this industry forward is really there being, and the Fermentation Association is doing this to a large degree, creating a community and also a bank of knowledge and resources so that we can continue to move forward and find information that we need quickly, find answers, find other people that are looking, have these same problems, and kind of collating them into a space where we can find things with a little bit more of a ready hand. With that said, there's a lot of scientific documents out there, but we don't always, as kind of lay people outside of the science world or the academic world or the university setting, have access to sometimes. So that is something of a resource that I think will continue to move this forward so that we can have greater management overall. And then, there's not one thing is finding more people who are really doing the microbiology of fermented foods in general. We are lucky enough in this moment to have two, I would say, of the best. And, there's a few more out there, but there's not that many of you guys, Ben and Maria, there's not that many of you that are really looking at the microbiome of fermented foods. So finding more knowledgeable, intelligent scientists who want to do this work, who want to really explore that which we're all doing, but do it on, the level of the science and academics, so that it can be a trickle down effect as well. And I know for me, like the access to get into a lab, I've been lucky enough to work with Ben in his lab over at Tufts, and it was just it opened my eyes up to a whole nother world from looking at, the microscopic level of what, let's say, the lactic versus the yeast look like under a microscope. Having that accessible within the lab as we build it out is something that we'll put in. So I can start to unravel and we can start to understand what's actually happening on a daily basis. Learning some of the kind of the basic microbiology techniques for looking at, for making plates and for doing all these other things that I would have never done before. I mean, I have my undergraduate degrees. I was studying Tibetan and in cultural anthropology. I wasn't in the lab. And so, this is so many years ago at this point now. If I could change it, I perhaps would. But having that sort of access and that having relationships start to form where we have makers and scientists really working together to understand process outside of the lab and in the kitchen and bring that in, and then for the makers to learn process within the lab. So at some point, these things start to link up and we start to understand more of what's going on kind of on all the levels of the process. For me, I know that's a big kind of gap and has been, and I feel like I've only gotten to dip my toe into it, but I know that I learned so much from my time in the lab that I want to do more of it so that I can continue to understand all of these little communities and, you know, as we say, invisible microbes that we're really in relationship with. So those are two of the, I would say, you know, the main things that are lacking in our community is more intelligent scientists who want to work with, you know, people in the culinary field, and then also just the resources being kind of collated for accessibility.
I'm just going to jump in really briefly because it was amazing to work with you, Cortney, to sort of learn what we can do to make this more accessible and to engage with the diverse world of fermenters. And I also think Maria might agree that it's actually really hard for us to get funding. I think that's for this kind of work, to study the good microbes in fermented foods. I think if any agencies are listening, you know, I think they're often considered fringe foods. You know, they're not your, you know, large commodity products for the most part. And so I think that there's not a lot of funding out there. So again, thinking about ways that we can all work together to, you know, champion funding for these kinds of efforts through the Fermentation Association or elsewhere, I think that's going to help build those resources and build that community. So, yeah.
Yeah, and I'll second that, of course. I think Ben and I started in a wave where probiotics and fermented foods were increasing popularity and are kind of in the public view more than they were 15, 20 years ago. And so, you know, we, particularly in the US, have opportunity here to really push this technology forward. And I think the TFA, organizations like this and sort of pre-competitive research offer a great opportunity for collaborative pre-competitive goals that are relevant to producers, to processors, and to chefs. So, you know, sort of a community, as Cortney, as you pointed out. Mateo.
Awesome. That was great, you know, and it brings to mind that there is a human fermentation in community building, and this is kind of apropos. So I'd say, you know, I think this is just an incredible time to be in fermented foods. There's just this like moment now where you have the arrival of technology, and the way I described being a cheesemaker when I started making cheese almost 20 years ago it was like being like a god, except you're blind and dumb, right? And you're like unleashing these like universes of life and then like wiping them out, and you couldn't see them. You could see the impacts of your actions, but you may or may not have control. And what's happened since we started making cheese is now the technology has enabled us to actually see what's happening. And, you know, I think this is like, you know, just this groundbreaking moment. We have the acceleration of knowledge. We're living in this moment where we can start to understand the things that previously could only be intuited. And I'd say that, you know, the advent of genetic sequencing and the work that we've done with Dr. Ben and his lab has opened up our understanding of our process in a really kind of profound way, and impacted the way we think about cheese fundamentally. All that said, you know, there's still all these like techniques and tools that are a little out of reach for your average producer. We built a microbiology lab to kind of house some of the knowledge and the hundreds and hundreds of strains that we isolated through work with Dr. Ben and Dr. Rachel Dutton early on in their exploration of cheese rinds. You know, it's one thing to like be able to catalog to see what microbes are present. It's a whole nother thing to understand how they behave and what kind of sensory or like you know, process related impacts they may have on your product, right? Microbes have been studied like ad nauseum in isolation, but developing tools and techniques to really understand how communities evolve and how they produce the sensory, the sensory, or even, yeah, for us, it's the sensory. It's like we're trying to basically connect like which microbial communities produce what sensory attributes, right? And it's that linking like the fermentation to the sensory piece that is still this like elusive, it's because it's so complicated, right? And there's so many dynamics at play, but we're hoping that over the next few years we'll be able to develop the tools to really connect microbial activity with specific sensory attributes. Yeah.
Mateo, it sounds like what you're describing is sort of a fundamental understanding of the ecology of these foods. We're also interested in needing diagnostics and ways to manage what you have already. Is that right?
Yes, absolutely. It's, we're in some ways, heading into this production of natural starters and like really the adoption of some very traditional like practices that go right back to like the primordia of cheese making. The production of rennet, like natural rennet, the production of these natural starters that are based on the flora of your milk. Wild, like there's a big natural wine movement, and I think there's a natural cheese movement coming, right? And we're looking at this biodiversity, which is fundamental to the expression of complexity and deliciousness, right? The enzymatic potential of our milk is really related to like the potential for flavor, right? And we look at these traditional practices that are in play in some cheese making regions and have been for hundreds and hundreds of years, but it's quite difficult to understand exactly like what's happening there, and where the flavor production is actually happening, and how that really integrates also with like the role of our farming practices and its impact on the microbial ecology of our raw milk as like a foundation and basis for flavor development and production in a finished cheese. Yeah, so much.
So much. Olivia?
All right, I actually have a slightly different, and this I think is probably an artifact of the scale that I'm working at and that I'm most familiar with. One thing that you do get as a benefit with scale is it's much easier to defray the costs of routine microbiological analysis. When you're taking a representative sample of a batch that is 100 pounds, you have to defray that cost, which can be pricey, especially when you get shipping to another contract laboratory involved. That can be a very significant economic impact. When you can take a representative sample of 2,000 pounds, suddenly your per unit additional cost that comes from your microbiological testing is much more reasonable, so long as your sample can be made representative. Obviously, it's not worth much if you don't have a representative sample. So that is one element of scale that works in our favor. One of the trappings of the scale, however, is I kind of alluded to before about the regulatory requirements. It often changes the burdens that you have and the speed at which you can pivot. Your losses are of greater, at least initial monetary value, maybe not percentage of your business, but the individual mass becomes larger and more expensive. But you're also able to absorb that a little bit better if you have a failed ferment. To me, while I find it very fascinating to know on a very microscopic level, pun not intended or intended, whichever you prefer, the exact biological, the enzyme activity, the exact microflora that you have are very fascinating. But unfortunately, that testing at current takes too long, to be perfectly honest. We on the production floor, so to speak, and on a daily basis with production, our understanding of the product is from effect rather than simply doing a DNA or even a group type analysis on some kind of exclusionary media to say, oh, these are this group or related group because it's an ability to process citrate. You know, any of those kind of stepwise identifications that we typically do in microbiology. I need to have a measure that I can do in minutes to maybe a couple of hours to know about the microbiological quality and just the overall status of the ferment. So what I would love to see, we are all, as everybody I'm sure is in this group, but all of us had mentioned pH being an important measure. And to greater or lesser extents, different targets may be required. And you may have to choose a target that isn't purely based on a quality parameter. You may like the flavor marginally better at a slightly higher pH, but for safety reasons and in your food safety program as written and validated and approved, you have to choose a slightly lower measure and make a happy compromise there. Obviously, if something's got to give, you must err on the side of safety. That's just, you know, you have to make foods that are safe to consume. And one of the elements of working at the larger industrial scale is you get audited, both by governmental bodies and by often GFSI or other third-party auditing schemes of various stripes. And you will be asked, how did you decide upon this critical limit? How did you determine this number? How do you know your products are safe? And you have to have a reason for that. And while you certainly can do an in-house validation, and depends on what you're testing for to get there, there's often, it's best to go back to some established between research and resources that are the coalition of many resource elements, you know, for example, put out by the FDA. They have pathogen tables that you can reference. So from a quality standpoint, to get back to that, I would most like to see whether it was a test strip would be fabulous because that's the most accessible for people of a lower training or that you could do on the floor rather than in the laboratory, because there's also regulatory requirements if you have a laboratory on site. So you opt yourself in to some oversight requirements, which come with an expense if you're going to do more stuff yourself. It's the other side of that coin. So a test strip, probably impractical. We already have pH test strips, which are not as specific as we need. Typically, we need a pH meter. But what I'd like to see is if there's some measure, whether it is carbon dioxide production, certain sugar utilization, or some way to measure in a relatively short window of time what phase of bacterial growth we're in particular, because those are so aggressive. We know about, though the exact shape changes a little, we know about bacterial growth curves. We have our lag phase, our log phase, our stationary phase, and then our die-off phase. Now, ideally, you probably want to be in your most aggressive growth phases early on in your fermentation to develop your flavor characteristics. And then you don't want to be quite so aggressive when it's in your package, because then you'll get puffing, bloating, off flavors because you've trapped gas. You've changed potentially your oxygen condition. So you may be, if you're still very aggressively fermenting when you're packaged, you may change pretty considerably your flavor profile, but you also may pretty considerably affect the effective shelf life of your product. If the product is so active for so long, it will drift a lot during the time it's packaged, even when cold. So being able to identify a growth phase without doing, a long form plating exercise, which can take days. Something that takes glassware, like to make a cheese analysis, doing a Babcock test for a fat analysis. That takes some chemicals, it takes labware, but it's very doable by somebody of an intermediate skill level and the appropriate protective equipment to do it off of the floor with cheese samples you collect that morning. Did that for a couple of years. So, for example, that sort of thing, or a closed vessel where you can measure the head space, air of that vessel to see what kind of gas exchange you've got, to measure by some means your fermentation vigorousness. And there's probably an element of this that would have to be unique to each facility, rather than saying, well, you're always good. The same way as pH is a little more broadly applicable, you may have to do some work inside. But right now, to my knowledge, there's not a lot on the market that you can do to assess your fermentation stage, so to speak.
Yeah.
And
it's a really great point that there's like this technology we need to sort of be able to track and predict the trajectory of ripening across products, which would be amazing. Yeah, at all scales. Yeah.
And to go back to what Cortney said earlier about the lupinostock in, I believe it was water kefir, being able to do perhaps a wet chemistry test or even a mass spectroscopy kind of test, because that equipment isn't actually that far out of the reach. It sounds like it's big and expensive, but A, it's been around for long enough, and B, there's little benchtop units. So as long as you can get the samples into it, it's not too bad on the upkeep. We're not talking about a 6-figure piece of machinery. It's a couple thousand, which as an investment for your quality on every run. Because I would like to see something that I can do to every product. The problem that we introduce when we only do extensive testing on defect batches is we lose sight of what's our normal batch.
Right. And this is something that Maria and I brought up in the last webinar of, having baseline data, which is a lot of work to get, right? That you have to collect it on what is good, but that can sometimes be really helpful when things go awry, as we sort of heard. Yeah.
Exactly.
So
being able to do that. Or,
I'm sorry to interrupt you, Olivia, but
no,
I want to make sure, this is great. And what I'm going to do is a shout out right now. This is just the beginning of a conversation that we're having at TFA about these kinds of issues. There will be a conference in November, from November 6th to 8th in Chicago, where we're going to be talking more about these issues, other microbial science, health, marketing issues as well. And you can check out the Fermentation Association website for that. And we'll continue these conversations with Olivia, Mateo, and Cortney in the future with that. So just so we have time to see what folks that are listening in might have questions about, Amelia is going to come back on and moderate some of the questions. But again, thank you, Olivia, Cortney, and Mateo, for just beginning this really exciting conversation. There's so much as a community that we're going to be working on in the future.
Yes, thank you. Thank you so much. This discussion has really been proof that chefs are scientists. There's so much, culinary and microbiology technique going into all of your crafts. One question we did have that came through. So how can farming practices impact the quality of your fermented food?
Mateo, do you want to talk maybe about some of your experiences and maybe also even Cortney, what you've learned from Stone Barns?
Sure. the microbial ecology of raw milk is the sum of the practices on a farm. So how you bed your cows, how you feed your cows, your water temperature, your facility design, your milking protocols, all contribute to the ecology in that raw milk. 90% of the microbes in raw milk actually come from this teat skin, the outside of the udder. And the rest are collected from equipment, or if there's intramammary infections, you'll get some, you can get some microbes from the udder. But one of the most incredible things for us, because we ended up purchasing a farm in the neighborhood that was quite conventional. It's feeding silage. We were making cheese with that milk, and we'd get intermittent listeria and clostridial blowing. The cheese, 4 or 6 months in, would just blow up like a basketball. And when we changed the feeding practices on that farm, those issues went away completely, right? And so just by transitioning from silage to dry hay, we were able to exclude pathogens and create a much more interesting microflora in the milk, which expressed itself in more interesting flavors, because the microbiology of the milk was more diverse, and also financially it was just a completely different experience, because we weren't throwing away tens of thousands of pounds of cheese. So that's in a simple way. You can change simple things. Your water temperature, raising your water temperature a few degrees can really alter the microflora in your milk as well, because you're going to scour your equipment in a way that is going to either select for thermophilic bacteria, lactic acid bacteria, and really keep some of the problematic spoilage organisms at bay. Is that enough?
So just to kind of touch on that one, we always say, and I mean, I think the science is maybe still out on it, that the microbiology and the healthy microbiome of our soil directly affects the food that we ferment from it. And so same thing, like happy animals make happy milk, happy soil makes happy vegetables. And the beauty of working with vegetables that are grown in soil that has a very diverse microbiome is that to ferment, it's like we're almost, in some ways it feels like we're cheating sometimes. There's all of this activation that happens. These vegetables are happy. They have bioavailable sugars. They're not lacking in any of their own nutrients that are going to displace what needs to happen in order to ferment them. So a lot of times, we'll get certain cabbages or carrots that are also so high in natural sugars because they're developing in this really amazing soil, and that makes our ferments go quickly. It allows us to keep a lot of textural austerity, and whether this is actually cause and effect, I don't personally know, but I know that when working with, we've done a lot of side-by-side tests of like conventional, older, non-organic regenerative vegetables versus what we're working with. We definitely see, obviously a flavor difference inherently. We're also, very deep in seed selection and variety control and all of that. So it's not necessarily apples for apples when we're taking like a Mokum carrot and then, a carrot that's been sitting, let's say in a bodega on the corner of somewhere in New York. They're very different things to start with, but the activity level and kind of the diversity of flavors that we're able to get are far greater. So we always believe that if we're putting good things into the soil, it starts there. And then what we eat therein and ferment therein directly affects, how we get to kind of diversify our own gut microbiome as well. So from a that's the chef science, not very deep, but that is what we're seeing on the farm. And same thing with the animals we raise. We're raising our pigs on all spent, waste-fed food, and the quality of the fat and the quality of the meat, because they're only eating things that are really kind of full circle on our farm, is absolutely mind-blowing. So there are some, again, sensory ways for us to determine these things, but we do see the activation of the ferments happening at a greater level and much faster with the vegetables that we're working with from really good soil.
And Olivia, at Wildbrine, when folks are sourcing raw materials from farms, is this something that you think a lot about in terms of the quality of the product coming in, the raw material that's coming in? You kind of alluded to this earlier, but are there things that you do from a QC perspective to think about what microbes are present or?
Yes, well, to a certain extent, as I was kind of mentioning before, part of the challenge with this is that a lot of the available methods take so long that they actually work themselves out of practicality.
Mm-hmm.
But it is something you have to have good relationships with your suppliers. Getting back to that difficulty with scale is once you're making enough, you have to have a pretty wide amount of suppliers, especially for fresh produce, in order to supply you for your year-round operations. So you have to foster these good relationships and be aware that there can be variation if you, for example, have to make a purchase on a spot buy market. That can be a very different experience. So doing very thorough inspections of your incoming produce is really important, especially to head off any early signs of spoilage. Having strict limits on how old post-harvest that things can be is important. But unfortunately, one thing you lose at scale sometimes is, though you have these relationships, you may not really be able to say, well, this isn't my farm. So, I can influence, I can make contracts or whatever it happens to be to purchase this quantity, but they're probably trying to grow more diverse amounts of vegetables as well that may not go to you. And so they have to, of course, there's economics involved, so variety control and so on would be lovely. And you do have some influence, but that is something when you get to scale, when you're no longer working entirely on your own farm, that you do have to have more relationship quality with those suppliers and a really good communication with them and establish specifications. Great. So it changes the relationship to the produce, but doesn't remove the importance of those elements that, like Cortney was talking about.
Well, I think just for the sake of time, we might wrap it up and encourage any other participants that are out there to reach out to any of us with additional questions. And again, keep your eye on the Fermentation website for more webinars. And I'll just say thank you all panelists, and maybe Maria.
Thank you. Thank you.
Well, thank you for having us.
Yeah,
it's been very interesting.
Yes, thank you. And
all.
thank you everyone for joining us. Thank you, Ben, Maria, Cortney, Mateo, and Olivia. For those of you watching, we will post a recording of this webinar on TFA's website in the next 24 hours. As Ben mentioned, registration is now open for TFA's first live in-person conference in November in Chicago called Fermentation 2021. Please go to fermentationassociation.org to get your ticket. We also have a number of great webinars coming up in the next few weeks: Beyond Kombucha, Pu'er, June, and Dark Tea, and the state of the art in coffee fermentation. Please go to fermentationassociation.org to check those out and register. And while you're there, subscribe to our YouTube channel and Instagram account. Thanks, everyone. Bye.